"There are more things in heaven and earth than are dreamt of in our philosophy," wrote William Shakespeare.
And in spite of the huge steps science has made in the past 500 years, his observation still holds true.
There are still more things we don't know about the universe than we actually do know.
To explain some of these mysteries, CERN, the largest physics research laboratory in the world, was created. And more recently, its Large Hadron Collider, or LHC.
If one looks at the universe, we can actually only see something like 4% of the overall universe. Almost all of it is invisible, either in form of dark matter which doesn't shine, which doesn't interact with light, or dark energy, where we don't even know what it could possibly be. And some of these dark matter or dark energy contributions to the universe might be visible, might make themselves visible in form of new types of particles that we hope to see at the LHC.
The thousands of physicists working at CERN are trying to solve the many riddles of the universe with no practical goals in mind.
But some of the very sophisticated technologies they develop to measure physics end up as useful applications in other fields, like in medicine, producing better X-ray machines, for example.
In the past, people had to be irradiated with very high dosage of X-rays so that you could actually see the shadows of the bones on a film. Now you can replace this film by very sensitive detectors, which means you can lower the dose dramatically. That allows you to take more pictures, or to take pictures even in form of a movie while an operation is taking place, for example, inside the brain. We're also working on things like crystals, very heavy crystals, which allow you to do PET scans at a higher sensitivity, or perhaps even put these PET scan detectors inside the body, which allow you to see parts of the body which in the past were impossible to scan. So these developments are coincidental to what we're doing. Of course, we're aware of these applications, and we have partnerships with industry to develop them further.
CERN physicists aren't in the game of developing better medical equipment, and neither are they studying new ways to produce energy. However, some of the experiments they carry out might have an impact on energy production in the future.
So CERN's never been looking towards producing energy, but some of the products of the research that we're doing might have implications, not so much in the production of energy, but in the longer term dealing with the secondary products of nuclear reactors, among other things.
In any case, scientists at CERN are following the energy debate.
It's a complex topic, of course, because you have to think about what nuclear energy is on one hand. You have to think about the overall picture of how to produce energy in the world, what climate change is happening. And in fact, CERN is participating to a certain degree even in this overall debate by doing a certain number of experiments, one of them specifically targeted toward understanding climate change more precisely, and the role of cosmic rays, for example, in the formation of clouds.
Here again, there's a nice example of how much science still needs to discover, if we're not even clear about clouds yet.
While recently the main focus at CERN has moved to the LHC, other labs are still very important.
This machine, for example, is an antimatter trap. Professor Dozer studies antimatter to better understand how matter works. And matter is what everything is made of.
You're talking about the moment of creation.
But what terrifying discovery would make the Vatican turn to him?
If you saw the film Angels and Demons, where the bad guys steal 1 gram of antimatter from CERN to make a bomb and blow up the Vatican, there's no need to panic. In real life, this could never happen.
There's no way we can get 1 gram of antimatter. We'd have to run CERN since the beginning of the universe, and then we would now have as much antimatter as was supposedly stolen from us.
Far from being evil, antimatter might prove to be quite a good thing. New radiation machines, which use antiprotons, have proved in tests to show promise in killing cancer cells.